Hi, my name is Ignatius Bonk, and today we're going to go over a numerical calculation of Python. Now, me and my 8-year-old son was having a conversation about the game of darts, and he asked whether or not I had to aim directly at the bullseye to hit the bullseye, or I had to aim above the bullseye to overcome the forces of gravity. And being that uh, the dart is so small and aerodynamic, and the distance, which is only about 7 feet from the dartboard, is kind of relatively short, and the, we throw it at a high speed, about 6 meters per second. Uh, Maybe I need to check this out, and I decided to set this up in this program. Now I went ahead. The first thing I did was define put a few definitions in. Go ahead and put some objects as well. We have the ground at 0. We have a dart release point at 0. It was released. I have it about eye height as me, and I have the two different darts. I have a steel tip dart and a soft tip dart. I wanted to try both of those out, and those are going to be set at the dart release points. And next thing we did was we have a dartboard and a bullseye, both in red, and they're going to be placed at the regulational height and the distance away from us. Um, and I went ahead and included the radius of each one as well. Now, next thing I did was define the gravity vector, and went ahead and put how fast the initial speed that I throw the dart. I went ahead and took some experimental data and found that I throw the dart at 6.6 meters per second for the steel tip dart and 6 meters per second for the soft tip dart. And we took the masses of each dart. We want to put that in there, and the next thing we want to do is find the actual velocity vector, and we could use the two initial speeds that they're going to be at, and use that as our x component, because we only have the velocity in the positive x direction, because I'm aiming directly at the bullseye, and the bullseye is level with the release point. Next two things I'm going to use is for each the soft tip dart and the steel tip dart. I'm going to use the momentum update formula, and we're going to have the start time at 0, and we're going to use really small time intervals. Time step's going to be 0.01 seconds, and we're going to attach a trail to each dart to kind of have a better visualization. And finally, we're going to set up two loops, one for the steel tip dart and one for the soft tip dart, and the loop is going to be it's going to calculate it all the way up until 2.37, which was where the dartboard's at. So basically, it's going to make these calculations all the way until it hits the board. And the rate it's going to do it at is real time. And we're going to find the force is the first thing we're going to do, which is just simply the mass times the gravity vector. Then next thing we're going to do is find the momentum using the momentum update formula. So it's the final momentum equals the initial momentum plus the force times delta t. Then we're going to have the position update formula, which is going to be the initial position. The final position equals the initial position plus the velocity, which would be the momentum times the delta t, and that's going to be divided by the mass of that particular dart. And we went ahead and used the momentum at that point in time after we updated it. We're going to use that final momentum in here to get our velocity, and that'll give us a better better calculation of the velocity rather than use my initial velocity. So we do that with both loops. We have the soft tip dart right here and steel tip dart. Now we'll go ahead and run this program and see what we get, whether we're going to hit that bullseye. Oh, nope, sure didn't. We're off by a long shot. Seems like the forces of gravity were really working on this one and pulled those darts down. So the answer is we need to aim higher to hit that bullseye, or throw it faster. Thanks, and have a good day.